And welcome back to my YouTube channel Spotify Learn. Today I'm here with the video of OS third module. Let's start with the important questions without wasting further time. If you are watching the video without subscribing to my channel, please do subscribe to my channel and then watch the video. And next I'll be uploading all the modules, so stay tuned for it. Now let's discuss the first question, that is they have asked define deadlock. What are the necessary conditions for deadlock to occur? Now, what is deadlock means? A process requests resources. If the resources are not available, a process is there, it will request some resources. Means ಅದು ಒಂದು ರಿಕ್ವೆಸ್ಟ್ ಮಾಡುತ್ತೆ ರಿಸೋರ್ಸಸ್ಸಿಗೆ. ಅದು ರಿಸೋರ್ಸ್ ಏನಾದ್ರು ಆ ಟೈಮಲ್ಲಿ ಅವೈಲೇಬಲ್ ಇಲ್ಲ ಅಂತಂದರೆ ಆ ಪ್ರಾಸೆಸ್ ಇದೆ ಅಲ್ಲ ರಿಕ್ವೆಸ್ಟ್ ಮಾಡಿದ್ದು ಅದು ವೆಯ್ಟಿಂಗ್ ಸ್ಟೇಟಿಗೆ ಹೋಗುತ್ತೆ. ಆ ವೆಯ್ಟಿಂಗ್ ಪ್ರಾಸೆಸ್ ಏನಿದೆ, ಆ ಪ್ರಾಸೆಸ್ ಏನಿದೆ ಅದು ನೆವರ್ ಏಬಲ್ ಟು ಚೇಂಜ್ ಸ್ಟೇಟ್, ಅಂದರೆ ಅದು ಸ್ಟೇಟ್ ಟು ಚೇಂಜ್ ಆಗಲ್ಲ. ಬಿಕಾಸ್ ದ ರಿಸೋರ್ಸಸ್ ಇಟ್ ಹ್ಯಾಸ್ ರಿಕ್ವೆಸ್ಟೆಡ್ ಆರ್ ಹೆಲ್ಡ್ ಬೈ ಅದರ್ ವೇಟಿಂಗ್ ಪ್ರೊಸೆಸಸ್. ಆ ರಿಸೋರ್ಸಸ್ ನಾವು ಏನು ರಿಕ್ವೆಸ್ಟ್ ಮಾಡಿರ್ತೀವಿ ಅದು ಬೇರೆ ಪ್ರಾಸೆಸ್ಸಿಂದ ತಡೆ, ಅಂದರೆ ಒಂಥರ ಹೆಲ್ಡ್ ಆಗಿರುತ್ತೆ, ಹೋಲ್ಡ್ ಅಂತಾರಲ್ಲ ಆ ಥರ. ಈ ಸಿಚುವೇಶನ್ನ ನಾವು ಡೆಡ್ ಲಾಕ್ ಅಂತ ಹೇಳಿ ಕನ್ಸಿಡರ್ ಮಾಡೋದು. ಅದಕ್ಕೆ ನೆಸೆಸರಿ ಕಂಡೀಷನಿಗೆ ಬಂದರೆ ನೀವು ಮ್ಯೂಚುವಲ್ ಎಕ್ಸ್ಕ್ಲೂಷನ್, ಹೋಲ್ಡ್ ಆ್ಯಂಡ್ ವೇಟ್, ನೋ ಪ್ರಿಯಾಂಪ್ಷನ್ ಮತ್ತು ಸರ್ಕ್ಯುಲರ್ ವೇಟ್, ಇದ್ರ ಥಿಯರಿ ನೀವು ಓದ್ಕೊಬೋದು. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಸ್ಟ್ರೇಟ್ ಪೀಟರ್ಸನ್ಸ್ ಸೊಲ್ಯೂಷನ್ ಫಾರ್ ದ ಕ್ರಿಟಿಕಲ್ ಸೆಕ್ಷನ್ ಪ್ರಾಬ್ಲಮ್. ಇವಾಗ ಪೀಟರ್ಸನ್ ಸೊಲ್ಯೂಷನ್ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಪೀಟರ್ಸನ್ ಸೊಲ್ಯೂಷನ್ ಅಂತಂದರೆ ದಿಸ್ ಇಸ್ ಅ ಕ್ಲಾಸಿಕ್ ಸಾಫ್ಟ್ವೇರ್ ಬೇಸ್ಡ್ ಸೊಲ್ಯೂಷನ್ ಟು ಅ ಕ್ರಿಟಿಕಲ್ ಸೆಕ್ಷನ್ ಪ್ರಾಬ್ಲಮ್. ಓಕೆ, ಇದು ಕ್ವಶನಲ್ಲೇ ಇದೆ. ದೇರ್ ಆರ್ ನೋ ಗ್ಯಾರಂಟೀಸ್ ದ್ಯಾಟ್ ಪೀಟರ್ಸನ್ ಸೊಲ್ಯೂಷನ್ಸ್ ವಿಲ್ ವರ್ಕ್ ಕರೆಕ್ಟ್ಲಿ ಆನ್ ಮಾಡರ್ನ್ ಕಂಪ್ಯೂಟರ್. ಈಗ ಕಂಪ್ಯೂಟರ್ ಆರ್ಕಿಟೆಕ್ಚರ್ ಏನಿದೆ ಅದು ಪರ್ಫೆಕ್ಟ್ ಇಲ್ಲ, ದಟ್ ಅದು ಕನ್ಫರ್ಮ್ ಇಲ್ಲ, ಅಂದರೆ ಇದು ಕರೆಕ್ಟಾಗಿ ವರ್ಕ್ ಆಗುತ್ತಾ ಅಂತ. ಇದು ಇಟ್ ವಿಲ್ ಪ್ರೊವೈಡ್ ಅ ಗುಡ್ ಅಲ್ಗಾರಿದಮಿಕ್ ಇನ್ವಾಲ್ವ್ಡ್ ಇನ್ ಡಿಸೈನಿಂಗ್ ಸಾಫ್ಟ್ವೇರ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ಸು, ಮ್ಯೂಚುವಲ್ ಎಕ್ಸ್ಕ್ಲೂಷನ್ ಪ್ರಾಸೆಸ್, ಬೌಂಡೆಡ್ ವೇಟಿಂಗ್ ಎಲ್ಲ ಇರುತ್ತೆ. ನೀವು ನೆಕ್ಸ್ಟು ಪೀಟರ್ಸನ್ ಸೊಲ್ಯೂಷನ್ನು ಏನು, ಇಟ್ ಇಸ್ ರಿಕ್ವೆಸ್ಟೆಡ್ ಲೈಕ್ ಇಟ್ ಇಸ್ ರೆಸ್ಟ್ರಿಕ್ಟೆಡ್ ಟು ಟೂ ಪ್ರಾಸೆಸಸ್ ದಟ್ ಆಲ್ಟರ್ನೇಟ್ ಎಕ್ಸಿಕ್ಯೂಷನ್ ಬಿಟ್ವೀನ್ ದಿಯರ್ ಕ್ರಿಟಿಕಲ್ ಸೆಕ್ಷನ್ ಆ್ಯಂಡ್ ದ ರಿಮೈಂಡರ್ ಸೆಕ್ಷನ್. ಟೂ ಸೆಕ್ಷನ್ಸ್ ಇರುತ್ತೆ, ಕ್ರಿಟಿಕಲ್ ಸೆಕ್ಷನ್ ಮತ್ತು ರಿಮೈಂಡರ್ ಸೆಕ್ಷನಲ್ಲಿ. ದ ಪ್ರಾಸೆಸಸ್ ಆರ್ ನಂಬರ್ಡ್ P0 and P1. ಇಟ್ ವಿಲ್ ಬಿ ನಂಬರ್ಡ್ ಆಸ್ ವಾಟ್, P0 and P1, PI or PJ. J is equal to I1 minus I. 1 minus I. ಇದರಲ್ಲಿ ಎರಡು ಡೇಟಾ ಐಟಮ್ಸ್ ಇರುತ್ತೆ, ಇಂಟ್ ಟರ್ನ್ ದಟ್ ಇಸ್ ಇಂಟಿಜರ್, ಬೂಲಿಯನ್ ದಟ್ ಇಸ್ ಫ್ಲಾಗ್. ಓಕೆನಾ. ನೆಕ್ಸ್ಟು ಯಾವುದು ಟರ್ನ್ ಇರುತ್ತೆ ಅಂದರೆ ದ ವೇರಿಯಬಲ್ ಟರ್ನ್ ಇದೆ ಅಲ್ಲ, ಈ ಟರ್ನು ಅದು ಇಂಡಿಕೇಟ್ಸ್ ದಟ್ ಹೂಸ್ ಟರ್ನ್ ಇಸ್ ಟು ಐದರ್ ಎಂಟರ್ ದ ಕ್ರಿಟಿಕಲ್ ಸೆಕ್ಷನ್. ಇಫ್ ಟರ್ನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಐ, ಇಟ್ ಈಸ್ ಅಲೌಡ್ ಕ್ರಿಟಿಕಲ್ ಸೆಕ್ಷನ್ನು. ಫ್ಲಾಗ್ ಇದೆ ಅಲ್ಲ ಇಲ್ಲಿ ಬೂಲಿಯನಲ್ಲಿ, ಅದು ಬೂಲಿಯನ್ ಟೈಪ್ ಅಂದರೆ ಏನೋ ಟ್ರೂ ಮತ್ತು ಫಾಲ್ಸ್ನ ರಿಟರ್ನ್ ಮಾಡೋದು. ದ ಫ್ಲಾಗ್ ಅರೇ is used to indicate if a process is ready to, ಅಂದರೆ ರೆಡಿ ಇದೆಯೋ ಇಲ್ವೋ ಅಂತ ಇಟ್ ವಿಲ್ ಇಂಡಿಕೇಟ್. ಇಫ್ ಇಟ್ ಇಸ್ ಟ್ರೂ ಇಟ್ ಇಸ್ ರೆಡಿ ಅಂತ. ಆಮೇಲೆ ಈ ಪ್ರೋಗ್ರಾಮ್ ನೀವು ಹೋಗ್ಬೋದು, ಯು ಕ್ಯಾನ್ ಸಿ ಇಟ್ ಆ್ಯಂಡ್ ಯು ಕ್ಯಾನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಆಮೇಲೆ ಯು ಹ್ಯಾವ್ ಟು ಪ್ರೂವ್ ದ ಸೊಲ್ಯೂಷನ್ ಕರೆಕ್ಟ್, ಮೀನ್ಸ್ ಯು ಹ್ಯಾವ್ ಟು ಶೋ ದಟ್ ಮ್ಯೂಚುವಲ್ ಎಕ್ಸ್ಕ್ಲೂಷನ್ ಇಸ್ ಪ್ರಿಸರ್ವ್ಡ್, ರಿಕ್ವೈರ್ಮೆಂಟ್ಸ್ ಇಸ್ ಸ್ಯಾಟಿಸ್ಫೈಡ್, ಬೌಂಡೆಡ್ ವೇಟಿಂಗ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ ಇಸ್ ಮೆಟ್. ನಾವು ಇಫ್ ಯು ಸಿ ದಿಸ್, if you want to prove mutual exclusion, that means it should enter into the critical section if flag of j is equal to false, turn is equal to I. ಅಂದರೆ ನಾವು ಇಂಟ್ ಟರ್ನ್ ಮತ್ತು ಬೂಲಿಯನ್ ಫ್ಲಾಗ್ ನೋಡಿತ್ತಲ್ವಾ, ಈ ಎರಡು ಟರ್ಮ್ನು ನೀವು ಅರ್ಥ ಮಾಡ್ಕೋಬೋದು ದ್ಯಾಟ್ ದಿಸ್ ಫ್ಲಾಗ್ ಆಫ್ ಅದು ಅರೇ ಆಫ್ ಜೆ ಇಸ್ ಈಕ್ವಲ್ ಟು ಫಾಲ್ಸ್ ಆಗಬೇಕು, ಇಲ್ಲ ಅಂತಂದರೆ ಟರ್ನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಐ ಆಗಬೇಕು. ನೆಕ್ಸ್ಟ್ ಏನಂತಂದರೆ if both processes are executed in their critical section at the same time, the flag of 1 is equal to 0 ಮತ್ತು 1 ಟ್ರೂ ಆಗುತ್ತೆ, ಮತ್ತು ಟರ್ನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಜೆ ಆಗುತ್ತೆ. ಫ್ಲಾಗ್ ಆಫ್ ಜೆ ಸೇಮ್, ಟರ್ನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಜೆ ಆದರೆ ಮ್ಯೂಚುವಲ್ ಎಕ್ಸ್ಕ್ಲೂಷನ್ ಇಸ್ ಪ್ರಿಸರ್ವ್ಡ್ ಅಂತ. ಮತ್ತು ನೀವು ಇಫ್ ಯು ಹ್ಯಾವ್ ಟು ಪ್ರೂವ್ ಪ್ರೋಗ್ರೆಸ್ ಆ್ಯಂಡ್ ಬೌಂಡೆಡ್ ವೇಟಿಂಗ್, PI is not ready, that means it says right, it is ready to perform or not, that is true or false. Now next let's discuss about the methods to recover from the deadlock. There are two methods, that is one is process termination and another one is resource preemption. Okay, now let's discuss about the process termination. Termination means what? To delete or to remove, like that it gives the meaning, right? To eliminate deadlocks. What is deadlock? You already know. That means you have to remove that deadlock by aborting a process use of two methods. In that both methods you will all the sources will be allocated to the terminated process. Now about all the deadlock processes, next is about one process at a time until the deadlocks like you will eliminate all. or you will eliminate one at a time. That means that both conditions you can see it. Now if partial termination method is used, you can have many factors, that is what is the priority, how long will it take, how many and what types of resources are there, how many more resources you need, how many process will be needed to in order to terminate, whether the process is interactive or batch, like that you can see. Next you can see the second method which I said was resource preemption. This means using a resource preemption, we will successively preempt sources from some sources from processes and give these resources to other processes until the deadlock cycle is broken. Okay, now if we see the preemption is required to deal with deadlocks, it will have three issues to be addressed. One is selecting a victim, one is the rollback condition, and another one is the starvation. You can see this all is about the theory. I'll explain very deeply about the numerical. Okay, now next is what is a resource allocation graph, what is a semaphore, state this using a dining philosopher problem. Okay, what this dining philosopher problem is, first what they have asked, what is resource allocation graph. Okay, basically what is resource allocation graph and what is semaphore, state a dining philosopher problem giving a solution using semaphore. Okay, and you have to implement an example to explain how it is useful in describing a deadly embrace. Okay, now what is, you know already what is deadlock, that can be described. Okay, you have deadlock means that will be described in terms of directed graph, that is called system resource allocation graph. Okay, now next, if you see what is semaphore means, semaphore is a synchronization tool to control access to shared resources and avoid race conditions. There are two types basically, that is binary and counting. Next, if you see dining, what is basically, I'll explain about the dining philosopher problem. Okay, there were five philosophers sitting around a table. Okay, circular table. Now each philosopher need two chopstick. What they need? Two chopstick. Okay, to eat. One this is and another one this, you think. Okay, it is a chopstick. Now one philosopher can use a chopstick at a time. Okay, means one here, one philosopher will be there, no, they can use only one at a time, but problem demonstrate deadlock and the starvation. Okay, this is the basic idea of what is dining philosopher problem. I hope you understood. Next is we will discuss about this, what is that. Next is this is a synchronization, as I said, it is proposed by Dijkstra, and there is wait, signal and all this, you will get it. Now see what is wait means, this if any other process it is in critical section or using other shared resources, that is called as what, wait. That is wait of s if while s is less than or equal to 0, no operation, that is comment. Okay, that is s minus minus you will do. Here what, s plus plus, that means you will be allocating the resources. Next, you can see here spending lives thinking and eating. There were in five circular chairs, five chopsticks and all. Now what is the solution means, one simple solution to represent each chopstick with a semaphore. Okay, now a philosopher tries to grab a chopstick by weight operation on that semaphore. She realizes her chopstick by executing the signal. Okay, that means she'll allocate it on the appropriate semaphore. Now semaphore stick of 5 because 5 members are there. Now while it is true, wait, then again percentage 5. Now you will allow at most 4 philosopher to sit at a table and next pick up her sticks, and if both sticks are available. Next is you can see each philosopher I invokes the operations pick up and pick down. That is, pick up means pick up that, put down means you should keep it. For each monitor you will take mutex, and next you will wait of mutex, signal of mutex will be there, you can see here. Next signaling, that is you will have the variable that is in integer type, that is next count. What is in the program that has been explained here, you can see this. Now next, another one important question of all here we discussed was the numerical here which it comes. Okay, now let's see what they have given. First they have given allocation matrix, what is the maximum value, what is the available value, and they have given 5 processes, that is P0, P1, P2, P3 and P4. Now let's discuss what is These mean, and they're asking for the need matrix. Okay, you remember need is equal to max minus allocation. That means you should subtract these both. Okay, now if you subtract 0 minus 0 is 0, 0 minus 0 is again 0, 1 minus 1 is again 0, 2 minus 2 is again 0. In the order of that particular process only you have to subtract and you'll get this matrix. Now what you need to do, you should check for the safe state whether it is in a safe sequence or not. Now what you should do, here you got the need table, right? Need table, you have to check it with work. Okay, now let us see what is work that is available which it have. Now what you have the for the process 10000, that you have to check whether it is less than or equal to. Now available is what? 0000. 1520, that is available, need is 00. Now you will check 0 is less than 1, 0 is less than 5, 0 is less than 2, 0 is less than or equal to 0. So now it is correct, it is agreeing this condition. So what will be the safe sequence? You will put this process, that is process 1, to the safe sequence. Okay, now next is what? See here, if you got this 1520, you need to add what? 0. See, you can see next max value 1. Sorry, here it should be, did I miss anywhere? See here you have P2, P1, right? You are doing for P1. You need to add this value, that is max value, as I said. 0012 you will add. Okay, you will get it as 0012, 2, 3, 5 and 0, 1. Again it will give 1, 3. Again you will compare with the next to this need value. Again it will be less. You will select. Again P4. This P2 it will not agree because 0 is less than, this will agree. 7 is not less than 5, it is greater, right? So it will not agree. You will not put in the sequence. Now once P5 is done, what you will do? Again you will go to P2. That means P2 is not done, right? You will check with the current value, that is 2, 14, 12 and 12. 0 is less than 2, 7 is less than 14, 5 is less than 12, 0 is less than 12. Now again you will add the max value for P2. See, you can see max value for allocation value you will add, that is see here, let me show. Here you can see this value. This values you will be adding 00632 and all. Now I'll erase this so you will not get confused. Next is you will check and again at last P2 will be coming. Okay, now what is the safe sequence? P0, P2, P1, P3, P4. Okay, that will satisfy the condition. How it will satisfy? That is, they have given a request, that is you will consider this as P1, P2, P3, P4, P5. Okay, now this will be P0, this will be P2, this will be P3. Okay, okay, this will be P3, this is P4 and this is again P1. Okay, this is what they have given here down. Okay, now next if you see what they have given, 0420, that is the request. Okay, if you want to see the request what they have given, you have to check it with all the needs, that is 0750, 0000, that and all you have to check and go, and you will get the available value and the need value. That will be conditioning, that is P0, P2, P1, P3, P4. Again you have to check with available and the need, that is need is less than or equal to available value. Now if you got, you will add that for sequence, that will be P0, P2, P1, P3 and P4. For this we check for safe sequence. Okay, that is according to this need table. Now they have given a request, that means the value for this available, you will check with it. This is all about the Banker's algorithm. If you solve one question, you will perfectly understand about this idea. I hope you have understood this video. Next, I'll be uploading the module 4 tomorrow. For that, stay tuned. Please make sure to like, share, comment and subscribe to my YouTube channel. I hope you understood all the numericals and theory parts. I'm not explaining more theory parts because even though if I explain again you need to study. So I think better you don't waste the time by this. So I hope you will prepare well and rock the exam. Let's rock it and thank you for watching the video. Next I'll be meeting with you next another video. Thank you.